Hi guys, we continue solving our task. So let's go to our nnetcode and check. So we have the tree, the new task as a new topic for today. So let's check the first task. Let's clear this up. So it's like should be a simple task. So let's check. So we're given a root of binary tree. We have to return the in order traversal of its nodes value. So we have 1, 2, and 3. So we have to return 1. Then 3, then 2. So here, for example, it's more complex. And our output should be 4, then 2, then 6, then 5. Okay, so let's try to find it. So we need to find to write a dfs function where we set our root, and this dfs function will will result. So we also need to create our list of integers. Integer, it will be result, new array list, and this list we will put here, and then we return this result. And let's write this dfs function. So it will be void dfs with tree node and list of result. So if root is equal to null, we just return. Otherwise, we on some value. So first we should go left. So we do dfs root left, and here result. And so when we go left, we now on the fourth element, and then we go up. So here we should add into our result root value. Then we go to the right and do the same. So only here we actually add these values. And let's submit. Okay, and we are done. So first done, let's go to the next one. All right, so let's clean this up. Post order, so we have now the same element, but we have 1, 2, 4, then 5, 6, 7, and then we go to 3, 8, 9. So when we just go, we do the same. So let's implement the same function as we have here, the same dfs function. And let's check how we can actually change this function. So if root, so now we actually, when we own the value, we try to add. So we add, and so on. So let's try. And let's submit. So the same function. And let's go to the next one. I'll also clean this up. So we have the same logic, but first we have go to, we have 4, then we have 6, then we have 7, and when we have 6 and 7, here we go to the 5. So first we clean all this. So let's try to use the same approach as we use here. So what do we have? So first we go left and right, then we add. And let's submit. Yeah, so we accept it as well. So let's try to solve the next one. Invert binary tree. So we have 4, 6, and we need to actually invert this binary tree. So we see, yeah, so how it works. So we have 4, 2 and we need to invert this binary tree. Okay, so given root of binary tree, we have to invert the tree and return its root. So root would be always the same. So we just need to invert, so we have to return root. Here root left, we should do invert tree root right, and here the same like root right, we should left, and if root equal to null, we return null. Okay, so let's think. So we have, first we go to left on 2, but we put it on right, so here it would be 2, right? And okay. Oh, okay, so that's not correct. Let's check our submission. So yeah, we need to store this left, yeah. So the problem here is that where we go, we actually update this value, and we need to store this value as right. Because we modified it inside. Yep, so now it works. Let's also mark it as done. And I think that's all for today. Thank you.